Hi, welcome to our first video for 5.5 data collecting and modeling. In this section, we're going to learn how to take a table of values or some collected data or information regarding periodic behavior. And then we're going to learn how to come up with an equation that fits or models that data. So this image right here shows a Foucault pendulum. Okay, that's from a French physicist. And he basically designed this pendulum that proves that the Earth rotates on its own axis. So right here is actually a string. It's a little bit hard to make out, and it's connected to this large mass at the bottom. So this is just a pendulum. It swings back and forth, okay, in a straight fixed path. However, because the Earth rotates on its own axis, so it kind of rotates around this way, it appears that the pendulum starts changing directions as it swings back and forth. So as the Earth rotates once around on its axis, if this pendulum was located at one of the poles, the North Pole, it would also look like it spins around during one day. So anyway, this if you're interested in finding more about that, you could Google search this or look it up on YouTube. But the reason why we're bringing this up is because a pendulum does actually show periodic behavior, because we know the pendulum swings out one way and then comes back, and that's one full cycle. So we could model the position or the height of the pendulum using a sinusoidal function. What we're going to do today, though, however, is we're going to actually look at a set of data, and this data is going to be periodic. And what we're going to do is we're going to interpret the information and then learn how to come up with an equation for it. Okay, so let's get started. So if we're going to try to come up with an equation for some, I guess you could say, sinusoidal data or periodic data, you would have to pick out some important information. So from that given data table, you need to determine the maximum, the minimum, which is usually pretty hard. It's usually pretty easy to figure out when you look at the data that's collected. You look for a maximum value, a minimum value, and then from that you can actually calculate the amplitude. And then after you figure those things out, you can then determine the period. So you want to interpret the data and find out how long it takes for one full cycle. And then finally, once you've decided if you're going to use sine or cos, you can then determine your phase shift in your equation. So all that information is going to help us get our parameters A, K, D, and C. And it doesn't matter if you're using sine or cosine. What matters is coming up with the right parameters. Okay, let's do an example. So in this table, it shows the temperature in Windsor, Ontario back in 2011. We will analyze the mean temperature column. So we'll analyze this last column here on the right. So we can see all the months are listed here. And then the mean temperature is like the average temperature for each month. Okay, so we want to come up with an equation that's going to basically model the temperature versus time or versus the month for that year. Okay, let's identify a few things. So we want to find the max value, max and min, and then from that we'll determine the amplitude and the period. So to help with this a little bit, I've actually opened up Desmos already, and I plugged in all the data. Okay, to do this, basically you can hit the plus sign, and then you can either add an equation, a note, or a table. I clicked on table, and it inserted this brand new table right here. And I just filled in all the data. I called January month 1, and then 2 and 3, all the way down to 12. And then on the Y column, I just entered in those into the table as well. So what's nice is you can then just adjust your screen and you can see all the data that's been collected. All right, so it kind of, if I look at the data, it looks like it has a little bit of like a sine or cos shape to it. And we can see max and min values. So we're going to come up with an equation that's going to fit that perfectly. So in the second entry, I'm going to start to kind of write my equation. So before I do that though, I need to figure out the parameters and then we'll plug that in. So what's the max mean temperature? So just scan this column here, look for the largest value, 25.8, that's easy. The minimum value happens in January, negative 5.6. The amplitude, so this is what we have to calculate. It's going to be equal to the max minus min over 2. So 25.8 minus a negative 5.6. So we'll be adding that and then divide that by 2. So I think that's going to work out to 31.4 over 2. So looks like about 15.7. So let's just double check this. 25.8 plus 5.6. Divide all that by 2. The divide symbol there. Okay, 15.8. Oh no, that doesn't make sense. 5.6, there we go. 25.8 plus 5.6 divided by 2, 15.7. Okay, so it looks like we had that right. So I'm just going to say, therefore, A equals, A is my amplitude, 15.7. Okay. So the period, how long do you think it'll take to complete one full cycle? Well, for weather in Windsor, and usually in most places in the world, it repeats on a yearly basis. So it's going to have a period of 12 months. Okay. However, I'm trying to come up with the equation, so I want to know the value of K, right? So period equals 360 over K. I can rearrange that for K. So we'll do 360 over the period. So 360 over 12, that's 30. Okay, so therefore K equals 30. So I'm just going to highlight a couple of these things here. There's A, there's K. All right, and probably would help if we determine maybe the phase shift. So it's a little bit hard to do though. At this point, let's enter this into our equation. So I'm going to start to model an equation that fits this, and we'll do cos first. So we're going to model something that looks like this. So I still got a few more things to calculate D and C, but let's just see how our graph looks for the time being. So we'll do y equals, amplitude is 15.7, and we'll do cos. We could have also done sine very easily, doesn't matter. The K value is 30, so we're going to have 30, and then I'll put X in my variable here. I might have a phase shift, so I'm just going to enter in a couple more brackets here. Okay, so far that's my equation that I have to fit the data. It doesn't look really good. It definitely needs a few adjustments. So when I look at the curve up here, I noticed that like the temperatures, the way this graph works is we're kind of beginning at a minimum value, right? At 1 negative 5.6, that's like a minimum. So cos always starts at a maximum and then goes down, right? So if I reflect this curve that I have here, I put a negative in front of the 15, that'll flip the curve. That already does a pretty good job of fitting the data. Okay, so I'm just going to add that in here. I'm going to say reflect cos to fit the data. Okay. And the next thing we need to do is probably change our center line, right? So where would our center line occur? Well, we know that the center line is equal to the maximum value minus the amplitude. So our max is 25.8 and the amplitude is just 15.7. So that is 10.1. So that's a good spot for the center line. I'm going to add that in here. This area plus 10.1. Okay, now our graph looks even better. So I'm thinking we still need to do a phase shift. So that's kind of why I said we'll kind of do this last, because it's usually hard to determine this until you kind of see the graph. So you could also think about it in picking out like a key feature of cos. So cos always begins with a maximum, but because we did a reflection, because we have that negative value, negative 15, that's in that equation here, that means it begins with a minimum. So our data, though, as you can see in the graph, our minimum happens at 1, not at 0, like this red point. So I should take this other minimum point and move it over so that it lines up. So if we do a phase shift of 1 degree to the right, it'll line up perfectly. So let's write that here. Phase shift of 1 to the right. So that means inside my bracket with x, I need to write minus 1. Okay, and now it looks a lot better. Still not a perfect graph, but it's pretty close. From this point, you could maybe make some slight adjustments. So I kind of feel like it could go a little bit more to the right. So I might do minus 1.5. Okay, maybe that was too much. So you could do some fine adjustments until you think you got something that fits pretty good. Okay. So once you have that, you can just copy out your equation. Okay, so I ended up using 1.4 for D for that. So I'm just going to hide the graph for a second. So you can see I determined all my important parameters, A, K, D, and C. So then I can just write out the equation. And I'm going to use appropriate values. I'm not going to use Y and X. I'm going to use T for temperature, and I'll use little t for time. So we can say T equals negative 15.7 times cos of 30 x minus 1.4 and plus 10.1. Sorry, instead of x, use little t for time. And that's a great equation right there. So let's say you didn't think about using cosine. You didn't really catch the whole minimum that happened at the beginning with this data. Or maybe you realize that it happened at month 1. So what's the point of using cosine? We might as well just shift sine, and that's totally fine. That equation would look like this instead. So we're going to do a second one here. I'm just going to use a positive amplitude this time. And I'm going to use cos. Okay, yeah, make sure your settings is in degrees, -2. So you're going to use cos. Everything stays the same. Sorry, we're going to use sine. Everything stays the same except for our phase shift, right? So we'll figure that out in a second. So that's our black graph. I want it to line up with the purple one or with the red points. So one way to do it is to identify the key features in the table. So sine, we know, always begins at the center line. You can see the center line on the graph there, where C is. Sine always begins there. You can see that point right at the y-axis on the black curve. I want to move that point to line up with the table of values, with the purple graph. So what I can do is, I know that C is 10.1, right? So I could then say, okay, where am I at positive 10.1 in this data table? So, and I want it to be at when it's at 10.1 and on its way up, like on the curve right over there. So I noticed in April I'm at 8.2 and then it jumps up right away to 15.5. So I'm somewhere between April and May. I'm at 10 and it's on a way to be increasing. So I want my sine graph to move from 0 and I want it to move to this spot in between those two, which would be like month 4 and 5. So I can go ahead and do that. I would have to shift 4 or 5 to the right. So I'll say -4. And I can go a little bit more. I'll write 0.5. Maybe that's too much. So I guess that's pretty good. So you can see how that works out quite nicely. Okay, and that's using a sine graph. So if you, let's say you're not using Desmos at all, you don't have any of this information, you don't know what the graph looks like, you have to try to visualize these points and see, okay, if I'm using cos, where's my maximum value? Okay, and or where is my minimum value, and then phase shift accordingly. So you're going to want your cos graph to match up with wherever that happens in the data table. If I was using sine starts at the center line and goes up. Well, that happens right around here in the data table. So I need to move my sine curve to match this. So I got to move about a positive 4.5 units. Okay, so that's how we handle these questions. And really, we're getting all our information from just a couple points, important points. So our max and min. Okay, we start with our max and min value, and then we determine the amplitude. We can then determine the center line using max and amplitude. And then it's easy to find the period and then get the p-value. And lastly, analyze the data table and see how much of a phase shift you need to do. Once you get A, K, D, and C, just put it all together inside that formula right there. Okay, hope you found this helpful. That's our first video. I'll see you guys in the next one.